Hello, everyone. Welcome to our webinar today on minimizing downtime with rolling upgrades in PostgreSQL. So, upgrading PostgreSQL can often feel like walking a tightrope. The stakes are super high, especially when the downtime can cost up to $85,000 per minute. That's why today, Semab Tariq, who is the speaker of the session and our PostgreSQL consultant at Stormatics, will share in a tutorial style how you can keep everything running smoothly during upgrades. And before we dive into that, I would like to share the usual housekeeping items. This webinar is being recorded, and the recording of the webinar will be shared afterwards. Feel free to use the Q&A feature or the webinar chat box for your questions or queries, and they will be answered at the end of the at the end of the session in the Q&A segment. And that's all from my end. Over to you, Sama.
All right. Thank you, Annie, first of all, and welcome everyone. I really appreciate you joining today's session. So I'm really excited to discuss a critical topic on minimizing downtime with rolling upgrades in Postgres. So now upgrades are very important to stay updated with the new features that provide security updates, performance improvements in Postgres, but they often come with the fear of downtime, which can, of course, disrupt your business operations as well. So in today's always on world, downtime is not just inconvenient. It can result in revenue loss, customer dissatisfaction, and even data integrity risks. That is why rolling upgrades are very important strategy to implement to and to have. And now today we are going to cover how we can actually minimize downtime during upgrades, bringing it as close to zero as possible. So before we actually get started, a little bit about me. So the name is Semab Tariq, and my first interaction with Postgres was started back in 2018. This is when I joined second quadrant as automation engineer. Then I moved to enterprise DB as DevOps engineer, and currently I'm working at Stormatics as Postgres consultant. And at Stormatics, we are keen to provide professional services for Postgres that include high availability, performance monitoring, and backups and recoveries. So this is kind of an agenda about what we are going to talk in today's or cover in today's session. So first of all, I will introduce you to what are the upgrades and why do we upgrade Postgres, and how many options are available in Postgres to actually perform upgrades. And then we are going to discuss the importance of minimizing the downtime for mission critical apps, and then I will go to a demo, and will show you how you can actually perform upgrade in real world scenario to bring your downtime close to zero. And finally, we will discuss some best practices for seamless transitions. Um, now, let's let's first try to understand what are the upgrades. Now, upgrades in Postgres actually means moving from one version of the database to another version, from an older or lower version to a newer or higher version. For example, upgrading from Postgres 13 to Postgres 14. Now, this process involves not just updating the software itself, but also taking advantage of new features like better performance, enhanced security, enhanced stability that comes with every newer version. So for example, for instance, if you are on Postgres version that is older than Postgres 16, you won't be able to implement or use bi-directional application feature that was introduced, or I would say that was fixed in Postgres 16. So in order to actually use that feature, you have to upgrade your system to Postgres 16 or newer. Now, why do we even perform upgrades? As I mentioned earlier, there are a couple of things that we take in example. For example, security is the topmost reason to perform upgrades in Postgres. Each new version include patches, issues discovered in previous releases, and staying on an older version can leave your system exposed to known threats, while upgrading can actually help ensure your system is updated with the latest security fixes. uh, then number two is performance. Now upgrades often bring significant performance improvements. These include optimized query execution, better memory management, and effective indexing as well. So and every new Postgres version include new features as well, and it is more stable. And finally, Postgres community provides 5 years of support for each major version that include bug fixes, performance improvement, and security patches as well. So after this 5 year period is over, we will not be able to receive the security fixes for the version that is older than that 5 years time. This is highly important to upgrade to a more newer or latest version. So Postgres community actually have a predefined sort of release cycle for Postgres releases. So there are mainly we call mainly there are two type of releases. The one is major version release, and the other one is minor version release. So major version release means a new major version is released. A new major version is released every year. So for example, Postgres 17 was released in 2023, and Postgres 18 will be released in this year 2024. So that major version upgrade means that if you are running up your Postgres instance on 13.x, that can be 13.1, and if you are planning to upgrade it on 17.x, so that will be a major version upgrade. So digit on the left side of that point is your major version, and on the right side is your minor version. So with each major version you can expect feature improvements, and every major release often include changes to database schema as well, and catalog as well. So which could require